Guys, okay, so let's get started. So now next we will be learning about the factors, prime factors, sieve, segmented sieve, and all that stuff. So let's start with factors of a number. Okay, let's start with factors of a number. So let's say if you let's say you have 12, you want to find the factors of 12. What you will do, you will try dividing by 12. If the remainder is 0, then it is a factor, otherwise it's not a factor. Similarly, you will try dividing it with 2, then similarly you will try dividing it with 3, 4, right? So like in case of 5, it's not equal to 0, so it's not a factor. 1, 2, 3, 4, 6, right? Or 6, all of them are the factors of 12, right? So where we need to go? Till 11 we need to go. 6, 7, 8, 9, 10, 11. From 1 to 11, for all the numbers we will try dividing this 12, and we will see for if any of the number, if the remainder is 0, then it means it's a factor. If the remainder is not 0, then it is not a factor, right? So, is it that the case? Because here, what will happen is you will simply like run a for loop. Let's say for let's say I equal to 1 to n minus 1, and you will check a condition. If n modulo I equal to 0, it means that's a factor. So you will simply see out I, right? So it's just one way of printing all the factors of a number, right? So now let's take an example of 36. Okay, so we know that like 1 is a factor, so 36 into 1 is also 36. Okay, so now let's keep moving on. Then what is the next factor? Let me write it in the reverse way. 1 into 36 is also a factor. Then we have 2. 2 into 18 is also a factor. Then we have 3. So 3 into 12 is also 36. Then we have 4. So I guess 4 9 is 36, right? Then we have 6. 6 into 6 is 36, right? After 6 we have, I guess, what we have after 6, we have again, let's say 9, right? 9 into 4 we have 36. So 12 into 3 we have 36. 18 into 2 we have 36. And then after that, 13 into 1 we have 36. But if you say this is my center point, right? This is kind of like my center point. So what is happening here is, like, after a certain number, the prime factors or the factors of the number are repeating itself. Like we have this 4, we have the 4 here, but we have the 4 here as well. We have 3 here, we have the 3 here as well, right? So we generally, what we observe is, after the square root of n, the prime factors or the factors of a number starts to repeat itself. Okay, so let's say if we see all of these factors and all of these factors, okay, so most of the factors are included. We are able to calculate all the factors before the square root n, right? So why to go till n, right? What we can do is we can simply run a for loop from let's say int I equal to 1 till square root of n, right? And what we can do is, now what we do is, here is the thing. If n modulo I equal to 0, then obviously that is a factor. Then we will see out, then we will see out we will see out okay, then we will add one more condition. We have, if this is I, then what is this? This is n by I, right? So if this is I, this is 2, this is n, so this is n by 2, that is 36 by 2, that is 18, this is n by I. And we have one case where I is equal to n by I, so we need to check if it's that case. If that is not the case, if I is not equal to n by I, because here 6 and this is 36 by 6, right? So both are equal. So except for that case, because that case will be included here if n modulo I equal to 0. Except for that case, if there is any other case, what we will do, we will see out n by I, right? So this way we will be having all the factors of a number, right? This way we will be having all the factors of a number with the complexity of square root of n, right? Bigger square root of n. So this is one thing. But let's say, let's just say, let's say somebody asks you to find let's say you need to print, let's take a very simple number problem. You need to print all the primes. You need to print all the primes, sorry, from 1 to, let's say, 10 raised to power 8. Okay, from 1 to 10 raised to power 8. Yes, 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 yes. So we need to print for all the numbers from 1 to 10 raised to power 8. Now obviously it will run for like something like about and approximately this much, right? So but this is not my efficient solution. We can further optimize our finding prime or printing this prime numbers thing. So for that we have an algorithm, we call it as sieve. We call it as sieve. Okay, so we will be creating a sieve. So let's talk about sieve. Okay,